Hello students and welcome to Math Weekly number 22. In this Math Weekly, our focus skill will be on writing equivalent expressions by factoring or expanding. Let's begin with a definition of what equivalent expressions are. Equivalent alone means to be equal in value, and an expression is a representation of an amount. So if you put them together as an equivalent expression, or equivalent expressions, that's two or more expressions that are equal in value. So two representations that make the same comparison or description in a different way. So let's begin with what it means to expand an expression. Expanding an expression is defined as removing the parentheses or other grouping symbols from an expression. The distributive property, which is how you expand an expression, states that the product of a number and the sum is the same as the product of individual addends and the number. This also applies to subtraction. So if you look at our graphic here, see how we have a sum being multiplied by a? If we don't want to add the two numbers inside first, we can take the number on the outside and multiply it by each one of the addends on the inside of the parentheses. So in other words, adding b and c and then timesing by a is the same as multiplying a and b together, multiplying a and c together, and adding those amounts together. The same is true for subtraction. So let's look at some examples of the distributive property, and we're going to start with a numeric example to prove to you that the distributive property works. Now, if you were going to do this traditionally, you would do the parentheses first. So 3 plus 2 makes 5, and then you would do 2 times 5, which is 10. But the distributive property gives you an alternative. It says if you don't want to add the ones inside first, you can multiply 2 times 3, so 2 times 3 makes 6, and you can multiply 2 by 2, 2 times 2 is 4, and add the two together. 6 plus 4 makes 10. So it's an alternative method to the order of operations that allows the parentheses to be removed without doing what's inside first, which is beneficial when we have algebraic expressions such as this one, where we cannot combine x and 8 because they're not like terms. So I can't add x and 8 because they're not like terms. This is a variable, this is a constant. But I can get rid of these parentheses by doing the distributive property. 5 times x makes 5x. 5 times positive 8 makes positive 40. So this expression is equivalent to 5x plus 40. So 5 times the sum of x and 8 is the same as 5x plus 40. These are equivalent. They are equal in value. Let's look at another example. This one has fractions, but the process will still be the same. We have 2/3 times the sum of 12/15 x and 3. So because we cannot add 12/5 x, which has a variable, and 3, which is a constant, together, we can still do the distributive property and multiply each of these two terms by 2/3. So the first step we're going to do is do 2/3 times 12/15 x. Sorry, 12/5, not 12/15. Multiply straight across. 2 times 12 is 24. 3 times 5 is 15. So we have 24/15 x. And we're going to do 2/3 times positive 3. So 2/3 times 3. Remember, 3 is the same as 3 divided by 1. So 2 times 3 is 6. 3 times 1 is 3. Both these amounts are positive, so we get a plus sign in the middle. Now, you could change these to improper fractions to mixed numbers if you wanted to. How many sets of 15 can we make with 24? One whole set. How many be left over? 9. and the denominator stays the same because it tells the size of the pizza. So we get 1 and 9/15 x plus 6 divided by 3 is 2. We can still reduce 9/15 by 3 to get 1 and 3/5 x plus 2. Let's look at one more example of the distributive property. So we have negative 1.5 times 2a minus 5b. So we're going to take negative 1.5 times 2a. A negative times a positive makes a negative. 1.5 twice is 3, so we have negative 3a. Now we can take negative 1.5 times negative 5b. Negative times a negative is a positive. 1.5 times 5. 5 times 5 is 25. 5 times 1 is 5, and 2 more is 7. And you get 7.5b. So let's move on to the second half of this Math Weekly. In this, we're going to learn what it means to factor an expression. Factoring an expression is the opposite of expanding a fraction. It means to use parentheses to multiply an equivalent expression by the greatest common factor. Here is an example of factoring. As you can see, both 6 and 3 could divide by 3. Both of these expressions have an x, so they could both be divided by 3x. If you take 6x and you divide by 3x, 6 divided by 3 is 2. X divided by x, remember x is just any number divided by itself is 1. 2 times 1 is 2. Likewise, 3xy can be divided by 3x. 3 divided by 3 is 1, x divided by x is 1, 1 times y is just y. So you can see that after you divide, that's what's left inside the parentheses. Let's do some practice problems together. So we're looking for what's the greatest common factor that both 4x and 12xy can both be divided by. So I know that I need to look at the lowest number. 4 can be factored by 2. What could be factored by 1, but that's not going to change anything. 2 and 4. Can 12 also divide by 2? Yes, and it can also divide by 4. So which one's the greatest common factor? 4. So both of these could be divided by 4. Now, with the 4 is an x. So this expression could be divided by x. Could the second expression be divided by x as well? Yes. So both of these could be divided by 4x. So 4x is going to be multiplying an expression to get an expression equivalent to 4x plus 12xy. So 4 divided by 4 is 1, x divided by x is 1, 1 times 1 makes 1, plus 12 divided by 4 is 3, x divided by x is 1, 3 times 1 is just 3, and leaves us with a y left over. So this is 4x times the sum of 1 and 3y. Let's look at another example. Again, I'm going to look at the lowest numeric value, which is 12. 12 can be factored by 1, 12, 2, 6, 3, and 4. So I'm going to look at 18 and see if any of these can divide by it. I'm going to start at the top because I want the greatest common factor. Can 18 divide by 12? No. Can 18 divide by 6? Yes. So both of these can divide by 6. Now, 12 also has x, so it could be divided by x, but can this one be divided by x? No, because it doesn't have an x value. Does this one could be divided by y? Does this one have a y value? No. So the greatest common factor that these can divide by is 6. 18 divided by 6 is 3, and we still have AB, plus 12 divided by 6 is 2, and we have x, y. This is the factored expression equivalent to 18ab plus 12xy. 10x minus 50. So I'm going to look at the lowest coefficient, which is 10, and I'm going to think about what it can divide by. 1 and 10, 2 and 5, and that's it. Now, I need to see which one of these is the greatest number that 50 can also be divided by. Can 50 be divided by 10? Yes. So I could divide each of these by 10. So 10 times an expression that will be equivalent to 10x minus 50. 10 divided by 10 is 1. 1 times x is just an x. Minus, or negative 50 divided by 10 makes negative 5. So I have 10 times x minus 5. So let's summarize what we've learned about equivalent algebraic expressions. Equivalent means equal in value. Equivalent expressions are representations that are equal in value. An expression can be factored or expanded to be an equivalent expression. Thanks for watching Math Weekly number 22.